Hello, Honors Calculus class. Welcome to the first video on quadratic equations. So by popular demand, I wanted to go over another equation where you put it into standard form, and then another word problem. So here's the equation, and I want to put it into the standard form so I can get the vertex. So what I'm going to do is, first I'm going to factor out the negative 7. So you keep the negative 1/2, and you have x squared minus 6x. And since I'm factoring a negative 7 out, it's really 7/2 that I'm factoring out, because I would do negative 7 times negative 1/2, which is positive 7/2, excuse me. Then I'm going to add half of b squared, so I'm going to add 9. But I really added negative 9/2, so I'm going to add 9/2 out here to cancel that out. So once again, I added 9 on the inside, but it was really negative 1/2 times 9, if you can see. So I added negative 9/2, so I have to do the opposite and add 9/2. I'm going to rewrite it in standard form now. So negative 1/2 times x minus 3 squared. That's what this factors into, a perfect square trinomial. And then on the outside, you get 18/2, which is 9. I'm sorry, you get 16/2, that's what I meant, which is 8. So the vertex is 3, 8, it's h, k, and I know it opens downward, but I can also get the y-intercept fast by plugging in 0 for x, and if you do the math on that, you should get 7/2, or about 3.5. Your x-intercepts, when you solve this, you could try just set it equal to 0. I'm going to let you guys try that part. You should get 7 and negative 1. So I'm going to plot all this information. So I'm going to go over 3 up 8. That's there, and then that's where your axis goes through. So the axis, I want to make that a little bit nicer. The axis goes through here. And then 7 for the one of the x-intercepts is here, and negative 1 is here. So I know it opens downward. I could also plot the y-intercept, which is right here, and there's a point right there then, because it's symmetric. So it opens downward. And I also knew it opened downward from the original equation. The a value here was negative, so I knew it was going to open downward, and it's going to be a little wider than the normal graph. Here's one more problem for this section. It is a word problem that's similar to one that's on the test. The daily production cost C in dollars for a textile manufacturer is given by this equation. So it's a quadratic, where X is the number of units produced. How many units should be produced each day to yield a minimum cost? So what I said in class was, think about the way this opens. Because the A value is positive, it opens like this. So the minimum cost is going to happen at the vertex. So we have to figure out that x value. So I'm going to find that not by completing the square, but by writing this down and plugging in my b and my a. So negative b, well, b is negative 110, that's your b. Here's your a, so I'm just going to plug them in there. So negative b would be 110 over 2 times a, which is 0.045. And when you divide that, I just rounded to the nearest whole number, which is 1,222 units. If you use your Wolfram Alpha or another graphing device, you'll see that that's where the minimum occurs. They didn't ask for the minimum cost, but I could then figure it out by plugging in 1,222. I just wanted to quickly talk about what this number means. So I'd like you to understand that type of thing. The 100,000 is when x is 0, so 0 units sold, 0 units sold. So that's your starting cost before you even sold anything or made anything. So that's all maybe the price of the machinery. Okay, thank you guys. I put down a note to try to look at pages 139 and 141. That will help you guys out with the quadratics.